Hi dear students, you are watching Study with Sheraz, and in today's lecture we are going to talk about the detection and measurement of the radioactivity. So first of all, the first method is the photographic method. This method is also known as the autoradiography, as the word indicates, photographic. So it means that there is going to be the use of a photographic film or a photographic plate in this method, autoradiography. Radio word is derived from the radiation, and the graphy means the writing or the making an image. So in this method, we interact the ionizing radiations with a photographic plate, and a resulting image is observed to measure the amount of radiation and their nature. So it's a photochemical process as a result of exposure of photographic plate coated with the silver bromide. The blackening is produced that's proportional to the exposure time and intensity of the radiation. So basically in this process we use a photographic plate, and a photographic plate is coated with the chemical compounds such as the silver halides like the silver bromide, and whenever the plate is exposed to the radiations interact with the chemical, that is silver bromide, and there happens a photochemical process that leads to the blackening of the plate, and the extent of blackening is directly proportional to the time of the exposure of photographic plate to the radiation and the intensity of the radiations. More is the exposure time, more would be the blackening, and higher would be the intensity of radiations, greater would be the extent of blackening, and more ionizing radiations cause more blackening. After the development of this photographic plate, the patches or the blackening is observed by visual methods, or you can say that instruments like the photodensitometer are used to study the thickness of patches or the extent of blackening of the photographic plate. And based upon the data from the photodensitometer, we can talk about the quantity of the radiation, or we can talk about the exposure time of the photographic plate towards the radiations. Basically this is the method that is same by which the Henry Becquerel discovered the phenomena of the radioactivity, as I explained in a topic of radioactivity, that he accidentally discovered the phenomena of radioactivity when the photographic plate coated with the zinc sulfide was exposed to the uranium salts, and he observed blackening or fogging of the photographic plate. Talk about the consequences of this method. So this method is not much suitable for the quantitative analysis. It's suitable for the qualitative analysis, where we can compare the amounts of radiation produced from the two different sources by comparing the extent of blackening, or we can compare the ionizing power of the two different radiations like the alpha and beta by the comparison of the extent of blackening. But we can't say that how much radiation has been produced or how much radiation has fallen on the photographic plate, because the patches don't give us a quantitative measurement, or they don't give us any data, quantitative data in the form of values and the figures. So this method is only suitable for qualitative analysis. This is not suitable for the quantitative analysis. The next method for detection and measurement of the radiations is the gas ionization method. Basically this method is based upon the ionization or ionizing properties of the radiation, and in this method radiations are used to cause ionization, and the resulting electrons and the cations are subjected to the electric field, and because of that electric field they are collected at their respective electrode, that's the anode and cathode, and because of the movement and the collection of that electrons and cations, there is produced a pulse of current, and that pulse of current is equivalent to the amount of ionization caused by the radiations. So these methods can give us some quantitative data about the ionizing properties of the radiations. So in this method we use ionization chambers that contain two electrodes, and there is present some type of gas or some substance is used as the ionizing material. radiations are made to enter in the ionizing chamber. Ionization is caused and the resulting ions are collected, and a pulse of current is produced that is recorded by the recorder, and a graph can be plotted to have the quantitative data of the radiations. In this method, there are two types of the detectors that are used. The one is the Geiger Muller counter, the other one is the Wilson cloud chamber. So first of all, we will talk about the GM counter. Basically, this is the experimental setup for the GM counter. Here I have written the merits and demerits of the GM counter, and I would keep on explaining the components and their purpose and their use in this chamber. So you should keep on noting down that points that are related to the functioning and the construction of the GM counter. So first of all, if we talk about the construction of the GM counter, so it consists of a metallic chamber or a tube. On one side, there is provided a mica window. So this is for the entry of the radiations in the chamber. So this is a metallic chamber that is linked with a source of potential difference. This chamber is acting as the negative electrode or the cathode, and here is provided a tungsten anode in the form of a thin wire. So this wire is acting as the anode, the lining of the chamber is acting as the cathode, and the anode and cathode are linked to a recorder and amplifier for recording the pulse of current that would be produced as a result of the collection of the ions. The chamber is filled with the gas, like the noble gases, it's argon. A high potential of the 1200 volts is the working potential in GM counter. So if we talk about the working of the GM counter, the chamber is connected to the potential source and radiations are made to enter in the chamber. Whenever the radiations enter in the chamber, they are having ionizing powers and they knock out the electrons from the argon atom, producing electrons and the argon cations converted into the Ar plus electrons. Ar positive argon cations being positively charged are accelerated toward the cathode, whereas the electrons are accelerated toward the anode because strong electric field is present between the cathode and anode. And as these ions are collected at the cathode and anode, because of the movement of these charges, there happens the production of a pulse of current in the circuit, and that pulse of current is sent to the amplifier and recorder, and the recorder can plot a graph showing the signals or pulses of currents with the passage of time. So this is the working of the GM counter. If we talk about the advantages, and so first advantage of the GM counter is that it's a very sensitive technique. It's a highly sensitive technique that can measure and detect a very small amount of the radiations. The second advantage is that heavy pulse is produced. In most of the cases, the magnitude of pulse of current is very high, so an amplifier is not needed. The third advantage is that size of the pulse is not dependent upon the type of radiations. Whatever the type of radiation, alpha, beta, gamma is used, the magnitude of pulse is almost same in all the three cases. If we talk about the disadvantages, it's not very sensitive for high counting rate. Why? Because there happens some dead time in which the GM counter is not able to record any further radiations. The second disadvantage is that it's unable to differentiate between alpha, beta and gamma radiations. As I explained earlier that the size of pulse is independent of the type of radiations. So if size of pulse is not related to the type of radiation, it means that we cannot differentiate between alpha, beta and gamma radiations. It can show that radiations are coming, but it cannot show that which type of the radiations are incoming in the chamber. So this was all about the GM counter. In the next lecture, we will discuss about the Wilson cloud chamber and the scintillation counters. So stay tuned with us. We will meet in the next video. Up till then, Allah Hafiz.